Welcome back to part 4 of inequalities. In the last video here, we're going to look at two last types of inequalities that are just a little more complicated. The first one here is C. We have 3 over x minus 1 is less than or equal to 1 plus 4 over x. Notice that we have two different denominators here, and there are two terms on the right side here. So we're going to have to do a little more to get it equal to 0 or have 0 on one side of the inequality. First, I'm going to subtract 1 and subtract 4 over x from both sides. When I do that, I have 3 over x minus 1 minus 4 over x. So my LCD is x times x minus 1 because of the x on the 4 over x and the x minus 1 on the 3 over x minus 1. So I have to build up my denominators so that they match. The 1 is going to be easy. We can just make it x times x minus 1 over x times x minus 1. But on this first one, we need to build this 3 over x minus 1 up by an x over x. That's a funny looking 1, but now it will have a common denominator. And for the 4 over x, we're going to multiply that one by x minus 1 over x minus 1, which is also equivalent to 1, but now the denominators will match. So now I have 3 over x times x minus 1, and I need an x in the numerator, minus x times x minus 1 over x times x minus 1. That's still equivalent to 1, but now it has an LCD that matches the rest, minus 4 times x minus 1 over x times x minus 1, less than or equal to 0. So now we just need to combine these all over one denominator. And I'm going to go ahead and distribute that negative x through to each term on the inside of parentheses. That will give me a negative x squared plus x and a negative 4x plus 4 all over x times x minus 1. Combining like terms, I've got 3x plus x, that's a 4x minus 4x, that adds to 0. And I have an negative x squared and a 4. So I'm going to write this as 4 minus x squared all over x times x minus 1. And again, these are all less than or equal to 0. I know that numerator is going to factor to 2 plus x times 2 minus x. And I know the denominator is x times x minus 1. And that's all less than or equal to 0. Now my number line, I know I will have vertical asymptotes at 0 and at 1. In the numerator, I know I will have roots at 2 and negative 2. So now I just go through and pick values on each interval. To the left of negative 2, I will pick negative 3 as my test value. Between negative 2 and 0, I'll pick negative 1. Between 0 and 1, I will pick 1/2. And between 1 and 2, I will pick 3/2. Substituting negative 3 in, I will have a negative times a positive over a negative times a negative. That will give me an overall negative interval. On the interval from negative 2 to 0, substituting negative 1 in, I will have a positive times a positive over a negative times a negative. This will give me a positive region, or positive interval. When I substitute 1/2 in, I will have a positive times a positive over a positive times a negative. This will give me a negative interval. Substituting 3/2 in on the interval from 1 to 2, I will get a positive times a positive divided by a positive times a positive, which is overall a positive interval. To the right of 2, we're going to substitute 3 in, and that will give me a positive times a negative divided by a positive times a positive. This will be an overall negative interval. And I can now list the intervals on which this rational inequality is less than or equal to 0. To the left of -2, it is negative. Between 0 and 1, not including the endpoints, it is negative. And to the right of 2, including 2, just remember you cannot include the endpoints of vertical asymptotes. That's these 0 and 1 points on the number line. Listing our intervals from smallest to largest, we'll have open paren -infinity, comma -2, close bracket, because we're including the -2, union, open paren, because we're not including 0, 0 to 1, not including 1, getting infinitely close to these values but not including the actual value, union, open bracket, 2 to infinity, close parenthesis.